Hello, very good day to you, and welcome to the new unit, Dynamic Earth. In this unit, we're going to be exploring the different properties of the internal layers of the Earth. So the Earth has different internal structures, that is when you go deeper into the Earth. As you may know already from your elementary science, the Earth has three structures basically. We have the most outermost one, which is the Earth crust. And then in between you have the earth mantle, and then you have the core. So the core is further divided into outer core and inner core. All right, so basically it's crust, mantle, then outer core, then inner core. But even though the outer core and inner core, they are both the core, but they are separated. That is because the outer core is in a semi-liquid state. It's a kind of a plasma. It's a semi-liquid, kind of liquid state. So it's different from the inner core that is completely solid. We're going to do more about that shortly. So if you take out your earth science reference table, turn with me to page number 10, and that is what we're going to be looking at today. So I want us to focus on, we're going to be focusing on everything on the page actually. So let's get started. We're going to look at this column, which is temperature. And we're going to look at this column as well, which has to do with pressure. And then we're going to look at this column as well that has to do with density. Okay, so let's begin with density. I'm going to zoom in a little bit more so that you have more clarity on it. So like I said moments ago, the earth crust, as you move from the earth crust into the earth's core, you will be moving from one layer into another layer. So on the outermost part is the earth crust. So the earth crust itself, if you study it this way, is made up of two kinds. The first one is the continental crust, which is the part that makes up our continent: Africa, North and South America, Europe, Asia, India. All right. Then why the other part is the oceanic crust, which is the crust beneath the ocean. All right, now both of them differ in density. One of them has a density of 1.7 because it's all the way on the top, so it is not very dense, it's not very squashed together because it is the outermost part of the earth. While the other type, which is the continental crust, is 3.0 grams per cm cube. That is the basaltic oceanic crust. So you need to know the difference. One of them is higher in density, one of them is basaltic, and one of them is granitic. All right, so continental crust is granitic, and if you recall, granite is very felsic. So if you look at granite here, granite falls on the felsic side, talking about our igneous rock. And then basalt, on the other hand, is very mafic. All right, which means it's darker in color. So borrowing that idea into this part of our ASRT, that means the continental crust is granitic, which means it's like a granite, which means it is felsic. All right, I want you to add that to your annotation. You can just quickly draw an arrow and say continental crust is felsic, and then basaltic oceanic rock is mafic, M-A-F-I-C. All right. Then as you move downward, you would observe something. The density is increasing as you move from the earth's crust to the mantle, to the asthenosphere, sorry, and then to the mantle, and then to the outer core, and then to the inner core. You would observe that density keeps increasing all the way down. So you see density here being 3.5 to 5.6, and then 9.9 to 12.2, and then 12.8 to 13.1. All right, so density increases downward as you go deeper and deeper into the earth. Now similarly, we're going to jump into the side of pressure. Now pressure also increases as you move inward. Remember, the more the load you have on something, the more pressure you are putting on it, the more exact pressure you are exerting on it. It's like I only have one book in my head versus if I have 1,000 books on my head, it's going to be more pressure on me. So you see that the earth crust, there is nothing on it, so the earth crust has very little pressure. All right, so I'm following that broken line. if you follow that broken line a little bit downward, you follow the broken line and then you read it off, you see that it falls to about 0 atmosphere, 0 million atmosphere. All right, it's important to note the units of measurement for each of these criteria that we are looking at. All right, next, as you go deeper into the Earth crust, you see below the asthenosphere, that broken line, if you follow it up, you see now we are above 0. Now that would be something around, guess, if you say 0.1 or 0.2, yeah, I definitely would take that. So pressure is increasing. Then as you get to the boundary, the lower boundary of the mantle, between the mantle and the core, you see that pressure has definitely increased now to something around, take a guess. Yeah, if you say 1.5 million atmosphere, then density definitely is increasing. And then if you follow through with this, you get a greater number all the way to the middle of the Earth, the centermost part of the Earth, which is the inner core. You see that density, pressure is all the way high up. So simply put, as you move downward, pressure is also increasing. All right, so take note of that. Add that to your annotation as well. Next, we'll look at temperature. So just for clarity, I'm going to take everything off so we have enough space. Next, we're going to look at temperature. So as you can look, temperature is very similar to pressure as well. As you go, I'm going to zoom in a little bit so we have enough space. As you go deeper into the Earth, you see that temperature is also increasing. For instance, temperature on the Earth's surface, just right on the Earth's surface on the Earth crust, you see that it's almost at 0. Then below the boundary between the crust and the asthenosphere, which is this broken line, once again, you're going to follow through that broken line, you would record a temperature of right around 1,000 degrees Celsius. All right, around that. And then as you go deeper at the boundary between the asthenosphere and the mantle, once again, you're reading that broken line off all the way down here, and then you will get a temperature reading there. You see that temperature is gradually increasing between each of those boundaries. All right, between each of those boundaries. So once again, as you go deeper and deeper into the Earth's core from the Earth crust, temperature is increasing, pressure is increasing, and also density is increasing. Also, don't forget your unit. All right, the unit for density is grams per km cube, grams per cm cube. Pressure is million atmosphere. Temperature is degree Celsius. The last thing we're going to look at is the depth. All right, so depth is right around here. Okay, so we're going to look at the depth of each of these layers of the Earth crust. Once again, we're talking about the crust, mantle, and core. So the Earth crust is the beginning. So if you draw it all the way down, your depth will be right around 0. Yeah. So the depth where you hit the asthenosphere is the broken line. Once again, you have to follow that broken line through, and then you see that the depth of the asthenosphere is just right around there. Definitely not 0. I'm going to zoom in close so you have a much proper view of it. You see the red line is not at 0. It has moved past 0. So if this is 1,000, somewhere around the middle here should be 500. And if this is 500, then this should be around 100. Don't forget the unit, kilometer. How about the boundary between the asthenosphere and the stiffer mantle, which is this other broken line, the second broken line? I'm going to draw it all the way down, and then we should be able to read that. That is a little more than 500. So if you give me 600, 700, you'll be accurate. How about the boundary between the stiffer mantle and the outer core? All right, which is this. You know, read it off. You can see that that broken line is just right before 3,000. So 2,900 kilometer would be a proper reading. How about the boundary at the inner core? I'll let you come up with a value for that. All right. Hopefully you got that right. So that is how we're going to be using this Esrt page number 10, inferred properties of the Earth's interior. All right. Once again, it's the Earth crust, the asthenosphere, and then the mantle, and then the outer core and the inner core. Now, the asthenosphere, which is what I just want to focus a little bit more on. The asthenosphere is a plastic mantle. It's a part of the mantle that behaves like a plastic, kind of semi-liquid as well, just like the outer core. So it drives this convectional current there. So because of the heat that is in between, I mean, if you look at the temperature, once again, it's all the way at 600 degrees Fahrenheit and 600 degrees Celsius. And that is hot, really, really hot. So there's convectional current, there is movement below the earth crust. So it generates convection, all right? It gets heat up and then it moves just like you see in a boiling water. So, and that is what creates the plate tectonic or continental drift or crustal movement that we've been talking about in the last unit, geologic history. So once again, the asthenosphere and the outer core both are semi-liquid state. All right, let's take everything out, and lastly I want to talk about the composition of the outer core and the inner core. So we see the outer core is made up of iron and nickel. The inner core is also made up of iron and nickel. The major difference between these two, of course, is their densities, and of course their different pressure, their different temperature, and their different depth, and one of them is semi-liquid while the other one is solid. Okay, so that's a very important distinction between both of them. All right, I wish you the best of luck with your exit ticket and see you on the outside.